Hello friends, welcome to Truth of Physics. Today I will solve a problem on quantum mechanics, and the problem is here. Find the eigenvalues and spin eigenstates of this operator S1 equals to Sx plus Sy. Now this problem is going to be very much simple and very much interesting for you guys, because it will correlate between quantum mechanics and mathematical physics. The eigenvalue problem, as you did in mathematical physics. Okay, spin eigenstates. Here spin eigenstates is a quantum word. Eigenstates means in mathematical physics, so what we did, the eigenvector. Okay, and this is the eigenvalue, simply eigenvalue. So Sx and Xy are what here? Here Sx and Sy are the x component and the y component of the spin angular momentum. Now the generalized form or generalized wave function of a spin half particle can be written as chi is equals to alpha chi half plus beta chi minus half. Now this can be written as alpha into this, means this is represented with a column vector like this, plus beta into this represent a column vector like this. This are the basis vectors called. So in this video I am not going to discuss it detailedly. Okay, so there is a beautiful explanation or beautiful theory on this, that how if we have an operator, suppose we suppose there is operator A operator which operates on this wave function, then what will happen, we can express these things in terms of matrix. So this is a beautiful thing, but I'm not going to discuss it here. I will make a video on this later. Now as we want to find the eigenvalue of S1, so we have to operate S1, the operator, we have to operate this operator on the generalized wave function chi, and we will get the eigenvalue, something suppose lambda. Okay, something suppose lambda is the eigenvalue, into we return the chi, right, the wave function. This is the eigenvalue equation, we know this. Now so what will be this? If we do this, Sx and Sy can be represented as h cut over 2 multiplied with this. This is what a sigma x, or we called it the Pauli spin matrices, this and this. Okay, so the value of sigma x is the matrix this. Okay, and the sigma y is this. Okay, so these are the values of Sx and Sy. So simply you can understand that what will the value of S1? So S1 is nothing but Sx plus Sy. So this will gradually become h cut over 2 0 1 minus iota, and here 1 plus iota and 0. This is our S1. So S1 chi will be equals to, so this will give us this. Here you can see that chi is represented with this column vector. How? You can easily understand from here, this will be nothing but our alpha and beta, this. So gradually this becomes this. Now if we calculate it, so this will be this, and from here you can understand that h cut over 2 into beta 1 minus iota is equals to lambda alpha. This is 1, and the another equation will be h cut over 2 alpha into 1 plus I is equals to lambda into beta. Now solving these two equations, you will get lambda square is equals to h cut square over 2, or lambda is equals to plus minus h cut over root over 2. If we calculate this, then you will get this. Now so this is what, this is the eigenvalue. Now there is another way of solving this, and which is pretty much similar with our mathematical physics methods, our S1. So from here what can we do? Okay, this is h cut over Okay, uh, this was our 0, 1 plus I h cut over 2, 1 minus I h cut over 2, and 0. So we have to just make a minus lambda to the diagonal terms, this and this. So what we'll get, this is the method, 0 is equals to this minus lambda, means minus lambda, and there minus lambda h cut over 2. This becomes now not a matrix, this is now a determinant. So okay, so we have to solve this determinant to find the value of lambda, the eigenvalue. So lambda square, from here you will get the similar result, each lambda is equals to plus minus h cut over root 2. So this is another method, a simpler method rather than this method. Okay, so this is the actual concept, and you can find, this is the actual concept, and you can find this method from this method. Okay, now we have to find the eigenstates of the operator S1. Now the process is quite similar in our like our mathematical methods. So we have the matrix, this, the matrix was 0, 1 plus iota h cut over 2, 1 minus iota h cut over 2. So first we will find the eigenstate for plus h cut over root 2. So what will be that? We have to just subtract this h cut over root 2 from the diagonal terms, this and this. So minus h cut over root 2 minus h cut root 2. This is multiplied with, suppose, x1 x2 which is equals to 0. So from here we will get like this. So from here you can understand that this will form a column matrix like this. When we'll put the value of x1, suppose 1, if the value is x2 is 1, suppose, then the value of x1 will be 1 minus iota divided by root over 2. This is what? This is now the this is our chi, the generalized eigen function, or you can say the eigenstate. Okay, so now you can see here, to normalize it, we have to just multiply it with 1 divided by root over 1 minus iota into 1 plus iota divided by root 2 whole square, means 2 plus 1. This. So what we will get, this is 1 minus I square, means this is root 2. So 1 over root 2. So 1 over root 2. We have to multiply it with this. Now this total term is normalized, and this is our final, the value of chi. So 1 over root 2, I can write it as 1 minus iota over root 2, or simply I can write this with 2 into 1 0, this matrix, plus 1 by root 2 into 0 and 1, right? So this is what, this is our chi 1, this is our chi 2, chi half, and this is our chi minus half, right? This is our chi minus half. Now similarly you can find the values of you can find the eigenvector or eigenstate for minus h cut over root 2. So what will be that? So for minus h cut over root 2, 1 plus iota over root 2, this, and here is 1 by root 2. So this, I can write this also like this, 1 over root 2 into 1 0 plus 1 plus iota divided by 2 into 0 1. So I hope that you have enjoyed this video and the concepts that I have discussed in this video, and you learned that how you can find the eigenvalues and eigenstates of the operator, this kind of operator. Okay, so share this video with your friends, and if you are new, then subscribe this channel and hit the bell icon to get the notifications of upcoming videos. So take care of yourself. Thanks for watching.